40. Okay, so we're going to look at section 3.1 today. Some of this will be reviewed because we actually looked at part of this the first week of class when we looked at things you were supposed to know before coming to college algebra, but we're going to review them again as if you haven't seen it before. So we talked about linear equations in Unit 1, and we're going to talk about quadratic functions today. So how you know that it's a quadratic function is it basically has x squared in the equation. So quadratic functions have x squared in the equation, and the graph is the shape of a parabola. So we kind of already looked at basic graphs when we talked about shifts and transformations and all of that. But we're going to talk much more specifically about just the pieces that make up a parabola today. So rather than give you a whole bunch of definitions, I want you to draw an axis, and I want to draw a parabola that's not centered maybe. So notice how I didn't use the x-axis to center that parabola. That was actually purposeful. So there's some parts that I want you to be able to identify, and I'm going to show you how to find them in an equation here in a minute. So what is this point that I just marked here? It's where the graph crosses the x or y-axis, so it's called the what? The y-intercept. Okay, there'll only ever be one of these, because if there were two, it would fail what test that we talked about on test 1? The vertical line test, okay. These two things are called the what? X-intercepts. Okay, you can have two of these. Okay, you can also have none or one x-intercept if you think about it. Yes? Yeah. Oh, you mean he can't get in the outside building? Yeah, go ahead. And then this point right here is going to be pretty important. We're going to talk about how to find it here in a little bit. But this is the vertex. The turning point of the parabola is called the vertex, and that's going to be the key to kind of getting the graph right. And then last but not least, there is kind of an imaginary line that cuts the parabola in half. It's called the axis of symmetry because it creates a symmetrical left half and right half to each other. Okay, what do you notice about the axis of symmetry compared to the vertex though? Yeah, it always runs through it, because if it's going to cut the parabola in half, it's going to have to run through that vertex. So we're going to use that relationship to our advantage. Okay, so here are the two forms for quadratic functions, and we're going to look at one probably more than the other. So the first one is the most common. This is the one that we looked at during review week, first week of class. Ax squared, bless you, plus bx plus c. Okay, this is called standard form. It's the most common that you're going to find. And just know that a, b, and c are real numbers. So these aren't going to be letters. They're going to be represented by numbers. So it might look like 2x squared plus 5x minus 4 or something like that. Okay, but it'll be an x squared equation. But the second form that we actually haven't talked about this semester looks like this instead. Okay, this looks like more of the type that we would see if we were talking about the shifts and flips and all that other stuff when we talked about transformations. But this is what's called vertex form. A is a constant. And it's called vertex form because we're going to be able to pull the vertex very easily out of this form, and we're going to talk about that in a minute. But just know that both of these are x squared equations. Okay, this one is just kind of a straight standard form. This one is more of a showing the shifting, showing the stretching, and all that kind of form. Okay. All right, so here are the things I want you to be able to know / find in a parabola. The first thing is if the number in front of x squared is greater than 0 or positive, okay, it means that the parabola opens upward. So what I mean by that is it's just a parabola where the curve opens upward. But if a is less than 0 or negative, then it's telling you that you flipped the parabola upside down, so the parabola opens downward. So if this number right here, the one in front of x squared, is positive, it's a normal parabola. If it's negative, it's an upside down parabola. Okay, so that's the first thing that I want you to know when I ask you about the detailed graph. All right, so let's talk about how to find the vertex. I always talk about that first because that is the most important point in a parabola. If you know where the vertex is, and frankly, if you know whether it opens upward or downward, you should be able to sketch it just from that single point, really. Okay, although we'll want a little bit more detail than that. Okay, so here are your two ways to find the vertex, and it all has to do with what form the equation is in. So if the equation is in vertex form, that second form that I mentioned that wasn't going to be as common, the vertex is just going to be h comma k. In other words, pull these numbers out of the form, and that will be the vertex. So we'll do one example in a minute, but you change the sign of h. Okay, you don't change the sign of k. Okay, and the reason you change the sign of h is because this formula has a minus sign in it. Okay, so if it's in vertex form, it's called that because you're able to readily see what the vertex is without doing much work. But most likely, I already mentioned it's going to be in the first form. So if the equation is in standard form, which is certainly going to be the most common, so I'm going to put a star by this one. So if the equation is in standard form of some sort, then you're going to do negative b over 2a to find your x. Okay, now remember your vertex is two parts. It's an x comma y because it's a point. And the y is going to be f of that value. This looks a lot more difficult than it is. Okay, all this means right here is that you're just going to plug in the x to get the y. Okay, so let's find the vertex of each of these. I'm going to give you kind of two quadratic equations in different formats, and let's talk about how we can find the vertex of each. So the first one looks like negative 2 times parentheses x plus 2 squared plus 3. And then the second one is going to look like standard form. So let's say it is this right here. X squared minus 2x minus 3. So notice this one already looks like parentheses form, right? This one doesn't. But what do you notice about the power of both of them? Both of them are squared. So they're both parabolas for sure. They're just in different formats. Okay, so the vertex of this first one is not supposed to be really that difficult. You just change the sign of this number and you pull this number out. That's it. Okay, so the vertex would just be negative 2 comma 3. Okay, so the vertex is really nice to find when it's in vertex form. That's why it's called that. But it takes a little more work when it's in this form. But remember, this is going to be the most common format that you're going to see. Okay, so to find x, the formula is negative b over 2a. You're going to want to start committing that to memory because we're going to be using it. So what do I mean by b and a? Like the number in front of x squared is called the what? Which letter? A, this is the b, and this is the c. Okay, so your number in front of x squared is a, your number in front of x is b, and then your constant is your c. Okay, so if I want negative b, and b is already negative 2, then what is negative b? It's going to be just positive 2, right? And then over 2 times a, notice there's no number here, so what's it understood to be? 1. So we get an x value of 1. Okay, I almost always have students stop there and be like, okay, the vertex is 1. Okay, well that's half of the vertex, right? But the vertex is a point, so it has to be 1 comma something. Okay, so to find that something, we just plug in the x we just found. So to find y, we're just going to plug in x equals 1. And we can do that, right? We have calculators if we need to. So 1 squared minus 2 times 1 minus 3. But I say we don't even really need a calculator for 1, right? Because that's just 1 minus 2 minus 3. So that would just be negative 4. So how I want to see your answer then is as a point. So the vertex is 1 comma negative 4. Okay, so always a vertex will be written in that format because it should always be an x comma y. Okay, so that's how we find vertex. We're going to practice a little bit more of that in a minute. But let's talk about how to find the other pieces of the parabola. We've actually already talked about x and y intercepts this semester, just not with parabolas. Okay, how do you find the y-intercept of anything, not just a parabola? How do you find any type of y-intercept? So I'm going to start you off. You set the x equal to what? Equal to 0, yes. Set the x equal to 0 and solve for y. Okay, so in order to find the x-intercept, or possibly plural, could be 2, then what do you guess we're going to do? Since we set the x equal to 0 to find the y-intercept, what do you think we'll do to find the x-intercept? Set y equal to 0. So I like to remember it like you set the other variable equal to 0 depending on which intercept you want. And then last but not least, let's talk about how to find the axis of symmetry. To be honest, if you have the vertex, you already have this. You just have to know how to write it. Spelled symmetry weird though. It should be 2 M's. Okay. To find the axis of symmetry, it's just a vertical line through the vertex. So it is always just x equals a number. Vertical line equations, this was on test 1 actually, always just look like x equals a number. Okay, so whatever the x value of the vertex is, then that's the number you'll use. All right, so before we move on to actually finding these things, I want to talk about kind of visually what you can expect for these parabolas to look like when we graph them. Okay, so the possibilities for x-intercepts for quadratic functions, which is what we're discussing today. All right, so here is the most common scenario. You've got an axis, and you have a parabola that is crossing the x-axis twice. Okay, so how many x-intercepts would this one have, this parabola? 2? Okay, so this one has 2 x-intercepts. Is there any way for there to have more than 2 if it's going to stay a parabola? There's not, right? Like it can't come back around and hit it a third time, right? That's impossible if we're having a parabola shape. But could it only hit once, maybe? So what would it have to look like if it was going to only hit the x-axis once? Wouldn't the x-intercept have to be like also the vertex? In other words, it would have to be something like this. Okay, so notice here it only crosses the x-axis one time. Okay, and then remember that there should be opportunity for there to be no x-intercepts, right? If you had a parabola that did something like this, and I asked you to find the x-intercepts, you'd have to say none, right? There is no x-intercept in this parabola. So these are your 3 options. You're either going to have 2, which is most common, you're going to have 1, or you might possibly have none, okay? But you'll never have more than 2. Okay, so let's look at a basic one with pretty small numbers, and let's see if we can find all the pieces of the parabola and then eventually graph it. So I want you to find the x-intercept, the y-intercept, and the axis of symmetry. For the function in 1b. And then I want you to graph it. Okay, and the reason I didn't ask you for the vertex is because that's what I already asked you in 1b. Okay, so let's just write down what we got for example 1. Recall that the vertex was what for 1b? Wasn't it 1, -4? Okay, so I'm just pulling that in, and now we're going to find the rest of the pieces. All right, so let's start with the x-intercept or possibly intercepts. The reason I write the s in parentheses is because there could be one or possibly none, or there could be more than one. There could be two. So we're going to set that equation equal to 0. So this is the equation I used in 1b, so that's where I'm pulling it from. Okay, so now I want to factor this. So you can either use AC method, okay, or you can remember that I don't probably need AC method if the coefficient or the number in front of x squared is just 1. Okay, so you can use full-blown AC method if you wish to, but I don't really think we need to on this one. I think we can just kind of figure out what factors of -3 add up to -2 since the numbers are small, right? What are the factors of -3 that add up to -2? It would have to be x minus what? 3, and then x plus 1. Okay. So now if I know this times this is 0, either this is 0 or this is 0. So it looks like I get 2 x-intercepts. Here it's 3, and here it's -1. Most of the time my math lab is going to ask you to list this as a point. So what point would this be? An x-intercept of 3. 3 comma what? 0. So I'm going to circle that. And then this one we would write as -1 comma 0. So pay attention on your homework to how it asks you to enter the answer in. Okay, often it'll tell you to write it as a point or some other format. All right, so those are the x-intercepts, so let's look at the y-intercept. The y-intercept is going to be easier than the x-intercepts were. We won't have to factor or anything like that because for the the y-intercept, I just need to set what equal to 0? X, right? So in other words, I just need to plug in 0 to this equation and see what happens. So I'm going to do 0 squared minus 2 times 0 minus 3, and I'm going to get -3. So you would either write this as y equals -3 or write it as a point. So I'm going to write it like that because I'm pretty sure that's how my math lab is going to request that you write it. And then last but not least, we just need to know what the axis of symmetry is. The axis of symmetry is just a vertical line, so it's going to be x equals something. Okay, so I can start you off on the format there. It's got to be x equals something. And then you just need to look at where the vertex was, right? So notice what was the x value of the vertex we already found in the last example? It was just 1. So the axis of symmetry is simply x equals 1. Okay, so you just look at whatever the vertex is and you pull that x value out and say x equals that, always. All right, so let's see if we can get a really good idea of what the graph looks like. So we only probably need to go out 3 in every direction because if you look back at your points, nothing was bigger than 3. Oh, I lied. We got the vertexes goes to 4, so let's go out 4. So let's mark the intercepts. It looks like we have one at 3 and one at -1. We have a y-intercept at -3, right? And then remember what I told you, the most important point is actually the what when you graph it. It's Well, the axis of symmetry, not so much. What's the point it runs through, though? The vertex. Yeah, that's the most important point. So 1, -4 is the vertex. So I always kind of mark this because it tells me that I need to make a turn there, okay? And then you'll make better parabolas if you just kind of graph them from the vertex out. Okay, notice it's opening upward, which we expected because this number in front of x squared is what kind of number? Well, it's not though, right? Positive, right? If it were negative, how would the parabola have been different? It would have been upside down, right? But because the x squared number, or the number in front of x squared was positive, it was an opening upward parabola. So I know you can graph these on your graphing calculator, but I'm going to expect, decent looking graphs, okay, where your points are really clearly marked when you're asked to graph them by hand, and you will be asked to do that on test 2 for sure. Okay, so let's do another one where we have to kind of go all the way through it. So I want you to find the x-intercepts, the y-intercept, the vertex, and the axis of symmetry. So on your homework, it's going to do just what I'm asking you to do here. It's going to ask you for all the pieces, and then finally it's going to ask you to graph it. And it's either going to ask you to use like your mouse as, the thing that plots the points, or it might even ask you to like match the right graph. Like it'll show you a whole bunch of parabolas and say pick the right one. All right, but let's say that this is the function I want you to look at for this example. So x squared plus 3x minus 10. So how do we already know it's going to be a parabola? Because we do. Because of the x squared. Any x squared equation looks like a parabola. Okay. So let's just jump in and find the pieces. So again, if you're used to using your calculator, you can certainly use it as a backup tool, but you're going to need to make sure that you know how to show the work. Okay. You're not going to get credit for what the calculator can do on your tests or on quizzes or anything like that. So I'm going to set y equal to 0. So notice, I don't think I need AC method again, okay? But remember, you can always go back and do it if you want. But when the number in front of x squared is 1, we can just ask ourselves, what are the factors of negative 10 that would add up to 3? So what are the factors of negative 10 that would add up to 3? 2 and 5, which one should be positive then? The 5 needs to be positive, right? Why does the 5 need to be positive? Because we want it to add to be positive 3, right? If that would have been a minus 3, then we would have flip-flopped those signs. Okay, so good. All right, so we end up getting 2 x-intercepts. So what are they? If you look at these and set them equal to 0, you're going to get negative 5 and what else? Positive 2. Okay, so if you're supposed to write them as points, and you most likely will need to, we'll write it as negative 5, 0 and 2, 0. Okay, so that's the x-intercept. So now let's move on to the y-intercept. Remember, there's only ever one of these, because it would fail the vertical line test if there were more than one. So we're going to find g of 0. This is usually one of the easiest things to find, because when you plug in 0, you're going to get a lot of things go away. So what are you only left with if you plug in 0 everywhere? Negative 10. Okay, so we get y equals negative 10. Or if we want to write it as a point, and let's assume that we do, we want 0, negative 10. All right, so let's find the vertex. Okay, so as I mentioned, this is the most important point, and sometimes it is the most difficult point to find. Okay, but I think we can do it. All right, so x is always negative b over 2a. So you always look back at your equation, and it's like negative the middle number over twice the first number, right? So what's the middle number in our equation right here? 3. So it'll be negative 3 over 2 times 1, or just negative 3 over 2. Okay, but that's only half the vertex, right? That's just the x part of the vertex. What do I still need to find? I still need to find the y. So I'm going to have to plug in -3/2, and I get that we don't love fractions, but this is one of the things that your calculator is good at. Your calculator can give you a fraction just as quickly as anything else. Okay, so we're going to plug in -3/2. So it's going to look like -3/2 squared plus 3 times -3/2 minus 10. I'm using this equation, our g of x equation. And then remember, you can use the math fraction key. So this comes out to be -49/4. So if you're asked to enter in the vertex, fraction form is usually the way to go. So -3/2 comma -49/4 is what you would enter into MyMathLab for the vertex. But is that going to be super helpful when you're trying to graph this guy? Not as much, right? So we also can look at the decimal form, and your calculator can give you that too. You just do top divided by bottom, and it'll give you a decimal. So this works out to be -1.5 comma -12.25. So I'm going to circle both of these forms. Okay, to be honest, I'd prefer the fraction form if all you're doing is finding the vertex itself, if you're not graphing. But if you're graphing, you're going to want that decimal form so that you can make sense of it all. Okay, but in the end, just make sure that you give what I call exact answers. In other words, these fractions can be written as decimals nicely, but does anybody know what, for instance, 1/3 is as a decimal? What's 1/3 as a decimal? 0.3 forever and ever and ever and ever. So in that case, you would have to use the fraction form. Does that make sense? So when I say exact answers, for this one, it actually could be either format. But when it's a decimal that's unpleasant, you need to use the fraction form. All right, and then last but not least, and then we'll get to graphing this. Honestly, the axis of symmetry you get for free. Okay, if you have the vertex, you have the axis of symmetry already. You just need to remember how to write it. So I'll start you off. It's always x equals something. And so what would it be this time? X equals what? What's the x value of the vertex we just spent time finding? -3/2. That's it. Okay, so it's always just x equals whatever this number is. Okay, so it doesn't matter what it is. Okay, so let's go ahead and graph this. I'm going to graph it like this because I need to go down pretty far. I need to go down to -12, actually a little under it. So I'm actually going to go down to 13. You don't always have to make your graphs, equal on all four sides. Because I only need to go down that far. I don't really need to go to the left and right quite that far. I only need to go to the left and right at least 5. And then honestly, I don't need to go up at all if you look at the y values, but you could go up 5 too if you wanted. So let's carefully place our points, right? -5 goes here. The other x-intercept is 2. The y-intercept is 10. Okay, but remember, that's not where you make the turn. So lots of my past students have always tried to make the turn right there, and that's not where it is. Okay, the vertex is actually where you make the turn. So we need to go back -1.5, right, and down a little bit more than 12. Okay, so we can do that. So back -1.5 and down just a little bit more than 12. So again, this is the important point because it tells you when to do what? Turn. So now you know your parabola goes up this way and then kind of up this way. It should be like a curvy bottom. It shouldn't look like a V. It should look like a U. Okay. And then if you wanted to, you could also draw the axis of symmetry as a line that cuts it in half. Okay, so let's do a couple of problems where maybe we have to do a little bit more work to find, say, the x-intercepts. The y-intercept is always pretty easy. The vertex is always pretty much the same. But finding the x-intercepts can be a challenge depending on what type of equation you have. So I'm going to remind you of something we did the first week of class, but we've all slept a few times since then. So let's say that I asked you to find the x-intercepts of this equation. Now, we know it's a parabola because it's what kind of power? 2 squared, okay? But the problem is I don't think I can factor this just by eyeballing it, right? The other ones were a lot easier because what was the number in front of x squared on the previous problems? It was a 1, right? But this isn't, okay? So remember, we use AC method in this department to really teach factoring, but if you have another solid method that another teacher taught you, stick with that. I don't think you have to do it my way. I just think that AC method, if you're not real confident in factoring, is a good way to go. All right, so I'm going to run through AC method, but just know that you need to refer to the first week's notes if you want a really more in-depth step-by-step process. But here's the AC method to remind you. First, you multiply A times C. So I would take 6 times -3, and of course I get -18. Okay, so this is what you want to try to think about. You want a factor pair of -18 that add up to 7. That's what you want. Okay. So you can list them on your paper, you can list them in your head. Okay, so what are some things that multiply and give us 18? So I'll give you the easy one. 1 and 18 gives you 18. Okay, what else? 9 and 2, and then what else? What other pair? 6 and 3. Okay, but we need to pick the pair that could add up to be 7, right? Remembering that since this is negative, what do we know about one of the numbers in the pair, not the other one? One of them's negative and one of them's positive, right? So which ones are going to work then? Which ones are the ones you just said? 9 and 2, right? Specifically, I want to choose what? What sign on each of them? Positive 9, negative 2. Good. Okay? So that's the one I want to pick, and the reason is I want it to add up to 7, right? Not -7. All right, so let's talk about what do I do with the pair once I pick it. Okay, well, the answer is you replace this term with 2 terms made up of the pair you picked. Okay, so I'm going to replace that 7x with plus 9x minus 2x. Okay, so I'm using a different color to show you what I changed from the original function, right? That's the only thing I changed. I pulled out 7 and I put in 9 minus 2 instead. Okay, how come I'm allowed to do that? What is 9 minus 2? It's 7. Yeah, so I'm not really changing anything. What I'm doing, though, is expanding it to 4 terms so that I can do something called factoring by grouping. Okay, so now that it's in 4 terms, I can forget these second 2 terms, right? And I can just ask myself, what would happen, what could I pull out of the first group? What do they have in common? 3 and an x, right? And if I divide this by 3x, I still have what? 2x. If I divide this by 3x, I still have what? 3. Okay. A little tricky, but notice there's no number that I could divide out from 2 and 3, but there is a minus sign, so anytime this is negative, you're going to want to do this. But we're going to divide out a -1. What's dividing by a -1 really going to do to everything? Not a whole lot, but what's it going to do? Make them change the sign of both of them, right? So yes, it will make them positive. So if I divide -2 and -3 by -1, I get +2 and +3. And the reason that's helpful to me is now what do you notice? This and this are what? The same? So now we can say, okay, they have this in common, and then they have this not in common. And then now we're ready to go, right? Now we've got it factored. So now you'll set 2x plus 3 equal to 0, and also 3x minus 1 equal to 0. So here you'll get -3/2, and here you'll get 1/3 if you move the terms over. So if you were supposed to write them as points, we would write them like this, right? We would say it's -3/2, comma 0, and also 1/3, comma 0. Okay, so when we reviewed that the first week, like I told you that was going to be a really important piece, and this isn't going to be the only time that you're going to be expected to know how to factor. So like I'm reviewing it here, but if that's too hasty and too quick of a review, then where can you go to review some more? You can go to the first week notes, okay, but you can also you can Google search factoring using the AC method and find all sorts of stuff. Okay, so I really strongly suggest if you haven't felt prepared for the factoring question on the comp exam, then now's your chance to kind of catch up with that. Okay, so you really are going to need it for this section. All right, so we talked about this the first week also. So what happens when something won't factor? Because there are stuff that doesn't factor. So when it doesn't factor, do you remember what we use as a backup? It's a formula that we use pretty much when factoring just doesn't work for us. Starts with Q. Do you remember? Quadratic formula, yep. And by the way, it's called quadratic formula because it's used for solving quadratic functions. That's why it's called that. Okay. So here's the formula. If you didn't remember it before, you are using this on your comp test also. But it's negative b plus or minus b squared minus 4ac. And then all of that over 2a. And really, again, this is just review, like you were expected to know this actually coming into this class, but you might need a refresher. But it definitely shouldn't be the last or the only time you've seen it, because you've seen it with me even during the first week. Okay, so what do I mean by B's, A's, and C's? What do I mean by that? The numbers in front of the x squared, the x's, and then the number by itself, right? So which one is the number in front of x squared again? A. Which one's the number in front of B? Or number in front of x, I mean, I just gave you the answer. B, right? And then the C is the constant all by itself, okay? So let's look at one like that where maybe we can't use factoring. But you know, my strong suggestion is that you try to factor. Only use quadratic formula when you have to, because it's kind of tedious, it's kind of long. All right, but this one's not going to factor. How can you kind of already tell? You'd want factors of 1 that add up to 4. Is that ever going to happen? No, like there's only one pair of factors that give you 1. What is it? 1 and 1, right? And 1 and 1 are never going to give you 4. Okay, so this can't factor. No matter how hard we try, we're not going to be able to use AC method. And so we're going to use quadratic formula instead. All right, so let's just kind of lay out what our A, B, and C are, and then we'll use our formula. So what's our A? 1. What's B? 4, and C is also 1. So here's what it looks like, and we're going to just go slowly and put the numbers in where they go, right? So we're going to say the formula, and while we do it, plug in the numbers. So it's negative B plus or minus the square root of B squared minus 4ac, and then all over 2a. So that's going to look like negative 4 plus or minus the square root of, because I need to do which part of this first. I have a whole bunch of steps, but which step should come first according to the order of operations? The squared should come first, right? So 4 squared is what? 16, okay? 4 times 1 is just 4. On the bottom, I just get 2. So if I clean this up, I get negative 4 plus or minus the square root of 12 over 2. So if you give my math lab this answer, we talked about this on week 1, it's going to say, yep, you're right, but your answer's not simplified. It just doesn't like it because it wants you to fully simplify it. So just to kind of remind you, this is how we did this on the first week. You break down 12 into its smallest pieces. You can use a factor tree. Okay. So what are two things that multiply to give us 12? 6 and 2 will work. You also could have used 4 and 3, but you keep breaking it down until you're at prime numbers. In other words, until you can't break them down anymore. So the square root of 12 is the same as the square root of 2 times 2 times 3. And remember, this is something we reviewed first week also. We're looking for groups of 2. Okay, so don't we have some groups of 2, right? Like, what are the groups of 2 that we have? We have some 2's, right? But what about the 3? It has no partner, right? So the 2's get to go out. The 3 has to stay in because he's by himself. So that's what we're going to bring up here. So this is actually negative 4 plus or minus 2 square root of 3 over 2. And then one more thing, only if you could pull something out of 1, 2, 3 spots. This, and this, then we'll cancel any like terms we have. So don't we have something in common here, here, and here? We have a 2, right? So this would cancel with this and leave a 2, but this would cancel with this and leave a 1. Okay, notice we never, ever, ever pull it out of under the square root. You never, ever do that. Okay, so in the end, we get negative 2 plus or minus the square root of 3. But just know that this is actually 2 x-intercepts. So if you were asked to list these as points, and again, I think in this section you are asked to list them as points, they're going to look weird, but don't overthink it. It's just negative 2 plus square root of 3 comma 0, right? Because it's the x comma 0 for the y. And then what would be the second one? The same thing, but minus, right? Okay, so notice these are the exact answers. If you were graphing this, what would you want to change these to so that you could better do it? You would want to change these to decimals, right? And you could use your calculator to do that, right? So I didn't ask you to graph it, but I'm just saying if you did have to match it up with a graph, you would actually need to figure out what those decimals were. Okay, so you would just enter in your calculator negative 2 plus square root of 3, figure out what that decimal is, and then do the minus 1 too. Okay, so let's do a couple more, and I'm not going to tell you whether or not factoring works or not. You're just going to have to try to figure it out. So let's say I wanted you to find the x-intercepts of the following. Can't spell today. So let's say it was 6x squared minus 19x minus 7. So we're going to try to factor first. So let's see if we can do it. So a times c is going to be 6 times negative 7, which is negative 42. So remember, this is what I want, right? I want factors of what? Factors of negative 42 that add up to what? 19, negative 19 in fact. Okay, so if you're having trouble finding them, you can list them off to the side. Okay, so let's list a couple of them, right? 1 times 42 would work, although one of them needs to be negative, right? 2 and 21, 3 and 14, and then 6 and 7. Okay, so which are the pair that we could use and combine to be negative 19, though? Yeah, these guys are the ones that we can use, right? So we're going to choose what specifically. Make sure your signs are right. Negative 21, right, and positive 2, right? Because it had to be negative 21, because what are they supposed to be adding up to? Negative 19, okay? So here's what we've got. So it's going to be 6x squared. So this guy is going to get replaced with how many parts? 2 parts, okay? It doesn't matter which one you start with, okay? So I can do plus 2x minus 21x as long as I make sure that the minus sign is in front of the 21. But you would have the same result if you did minus 21 plus 2. So the purpose of this, remember, is to factor by grouping. So what can come out of the first grouping? What does the first group have in common? 2x. Okay, if you divide a 2x from this guy, what's left? 3x. If you divide 2x by itself, it's not gone. There's actually a what left? 1. That's kind of a tricky one, so I wanted to make sure we did one like that. And then what about here? What number do 21 and 7 both have in common? 7, but I want to pull out a negative 7. Anytime this number is negative, we want to actually factor out a negative 7. So negative 21 divided by negative 7 is positive 3, right? What's negative 7 divided by itself? And actually, this isn't 7x. It's supposed to just be what? Just 7, sorry. Okay, so just 7. But 7 divided by itself would just be a plus 1. Okay, so notice that we get a repeat. And that's actually always what we're supposed to have happen if it's factorable. And it looks like this one is. So we get 3x plus 1, and then 2x minus 7. And then what do we do with each of them then? Set them to 0. So we've already done all the hard part. Now we just need to do a little bit of arithmetic to move terms around. So here we'll get negative 1/3. And here we'll get 7/2. So the points then are negative 1/3 comma 0 and 7/2 comma 0. Okay, so if you can factor, do. Okay, if you can factor, I want you to do it. Okay, so the last one like this, and then we're going to look at a word problem that might be quadratic in nature. So x squared minus 2x plus 3. So I wanted to pick this one specifically because I know you might think this looks like it can factor, and I can see why you'd think that. But this one actually can't factor. Okay, and let's talk about why. It's because no factors of 3, positive 3, could ever add up to negative 2. And think about that quickly with me, right? It can't be 1 and 3 because that doesn't add up to negative 2. But it also can't be negative 1 and negative 3, right? Wouldn't both of them have to be negative? Why would both of them need to be negative? Because it's a positive 3, right? So it's close, but it actually doesn't work. If this were a minus sign, it would work, but it's not, okay? So what do we do when it won't factor? Yeah, we're going to use quadratic formula. Okay, so again, we're going to lay out what our A, B, and C are. So A is 1, B is negative 2, and C is 3. So here's our quadratic formula. It's negative B. Okay, so what is negative B if B is already negative 2? Positive 2, so it's negative B plus or minus the square root of B squared. Remember, when you have negative numbers, put them in parentheses. Minus 4AC, and then all over 2A. So let's go ahead and do as much of this as we can. Okay, negative 2 squared, careful about your signs. What's negative 2 times itself? Positive 4. But then this is going to be minus 12 because that's a -4 times a +3. So what you end up getting, the more you look at it, is something unusual, right? Notice we have a negative under the square root. So what kind of solutions are these? I want to write this down. These are imaginary solutions. Anytime you have a negative under the square root, as long as you're sure that you've done it right, it's imaginary solutions. Okay, but what were we looking for? We were looking for x-intercepts, right, which are tangible, graphable things, right? Can we graph imaginary things? We can't, right? So what does that mean about our x-intercepts then? It means there aren't any, right? It means there are no x-intercepts. So notice, you don't even have to necessarily go any further with that. You can just say, hey, I got imaginary solutions, there are no x-intercepts. And remember, we looked at one that was like that, right? This is what it looks like if there are no x-intercepts. The parabola is like floating and it doesn't ever touch the x-axis, so it's completely possible that that would happen. Okay, so the last thing that I want to look at with these parabolas involves something I feel like you'll already really know what they are, just maybe not how to find them. Okay, so with parabolas, well, actually just in general, what is the minimum in general, like apart from parabolas? The lowest point, right? And what's the maximum? The highest point? So here's kind of our two scenarios. So let's look at upward parabolas. That's the general one we draw the most often. Okay, so here's an upward parabola, right? So if you look at that kind of quick sketch, which of those is an upward parabola going to have, a max or a min? It's going to be the min, right? So notice the min is actually the same place as the what? The most important point that I've been mentioning? The vertex. Okay. Notice there's no max, right? Because it just keeps climbing forever and ever and ever. But notice that's opposite for downward parabolas. So if we have a downward parabola that looks something like this, what do you notice that it's going to have, and then what is it not going to have? It's going to have a max, and by the way, what's the max? Still, the vertex. Okay, so the extreme, no matter if it's the high or the low, is always the vertex, but in this case there would be no what? No min, because it keeps going down forever and ever. So if you're given an application problem, which is just a fancy way of saying a word problem, just know that you're never going to be asked to find anything different than what we've already been finding for parabolas. So I'm going to keep this brief, but let's say that a company sells a product X and has a profit function that looks like the following. So you're going to find with like business type examples like this one that you're going to have some decimals in the problem a lot of times. Okay, but that's okay. All right, so let's say this is the function and I want you to find how many units you need to maximize the profit. And I want you to find that maximum profit. So the key is I want you to maximize the profit. In other words, I want you to find the max. Okay. So let's see if we know how to do that, right? What do we know since this has a minus sign? What do we know because of that? It's a downward parabola, right? So if I want to find the max, what's it really asking me for? The max is just the vertex. Okay, so I don't have a formula for max, but I do have a formula for vertex. What is it? At least the x part. How do you find the x part of the vertex? Negative b over what? 2a? So we have a calculator and we'll use it. So it's negative b over 2 times negative 0.02. Notice, what did I put around the whole denominator to make sure my calculator knows what I want? Parentheses, okay? So if you plug that in the calculator, and I forgot my calculator today, but you can try it later, but you end up getting 2,500 units. Okay, so this is the amount of units they should sell if they want to earn the maximum profit. Okay, so that's the first thing I asked you for. And then it says find the maximum profit. So what will you do with that 2,500 once you know it will give you the maximum profit? You just need to what? Plug it in, right? We have a profit formula, so we're going to use it. So the max profit is just going to be whatever you get when you plug in 2,500. So you're going to do negative 0.02 times 2,500 squared plus 100 times 2,500, and then minus 80. Okay, so again, I didn't bring my calculator today, but I already did these ahead of time. So if you were to plug that in, it would be 124,920. So if you were advising this business owner, what would you tell him? He needs to sell how many units? 2,500, and if he does that, then how much profit will they make? $124,920, right? Okay, because that's where he wants to be, right? If this is your profit, you want to be right here, right? You want to be right at that peak. You don't want it to start going downhill again. Okay.